This is a video tutorial for Phil 123, Module 10 on behaviorism and the Turing Test. Now, a fair bit of stuff about Turing and the Turing Test you should already know, most notably that Turing was a mathematician, a computer scientist, and a philosopher, and Turing proposed a certain kind of test for determining, in his words, whether or not machines can think. Now, this is going to be a really important discussion, especially having followed our discussions of the mind-body problem. And in fact, the kind of position that someone like Turing is staking out is really related to that particular problem. I want to talk about, first of all, what exactly Turing is up to and how Turing's sympathies sort of fit into the literature on the mind-body problem that we've already discussed. Now, importantly, when Turing starts out his discussion with the question, can machines think? A couple things are important to keep in mind. First of all, what does he mean by thinking? Well, we'll see exactly. There's some things that think does not necessarily indicate, but we'll come back to that. Furthermore, when Turing's asking whether machines can think, he doesn't mean to ask whether or not television sets can think or whether or not automobiles can think. Those are machines, but not the kind of machines Turing has in mind. What Turing has in mind is what we would call a computer, something with software and hardware, a particular kind of processing unit capable of producing certain kinds of outputs, and so on. And it's going to be machines, namely computers, that are the best apt candidates for determining whether or not a machine can think. Now, what Turing suggests is that the question, can machines think, is problematic and difficult to answer for any number of ways. So he aims to substitute that question with another. Quoting now, what will happen when the machine takes the place of another player in this imitation game? Now, Turing asks us to initially consider one kind of an imitation game. In this case, what we're supposed to imagine is it's a game in which one individual is imitating another, specifically in which a man is going to imitate a woman. What we're supposed to imagine is that you, for example, get to ask questions. You get to ask questions of two different subjects. Call them subject A and subject B. Your only way of interacting with subjects A and B is by typing messages into a computer and reading their typed messages back. You can ask them any kinds of questions they want, and they can respond however they seem appropriate. Player A is a woman, and her job is to convince you that she is, in fact, a woman. Player B is a man, and his job is to convince you that he is, in fact, a woman. So one player is going to speak to you truthfully, the other one is going to try and fool you. What Turing proposes in this game, right, so this is how you win. You win if you guess correctly, if you figure out who's lying and who's really a woman. The players win if they get you to guess what they want you to guess, right? So the woman wins if she convinces you she's the woman, and the man wins if he convinces you, wrongly of course, that he's the woman. Now, obviously, there's some things built into the interface. You can't just look at a person. You can't get, that kind of physical information from them. The only information you're allowed to get is the kind of information that comes from asking questions and having them answered. That's it. That's the first kind of imitation game. That's supposed to suggest a second type of imitation game, and this has come to be called Turing's test. In Turing's test, the man and the woman are replaced by another human being and a computer, perhaps a very sophisticated kind of computer. In this particular game, the human being's object is to convince you that they are the human being. The computer's object is to convince you that they are the human being. Now here too, you can't look at them. You can ask any questions you like, but the person/computer is going to be motivated to answer them in a way that's going to help them win. Just as if you ask the man, "Are you a woman?" he's going to be motivated to give you information that makes you think he is. The computer will be, if you like, motivated to try and convince you that it is actually a human being. Even better, that it is thinking. So this is the second kind of imitation game. So it's an interesting question. Do you think you could accurately and reliably pick out who's the computer and who's not? There's ways of simulating Turing tests, and it's actually harder than you might think. Again, the only information that you're allowed to gather is information that can be asked and answered via questions on a computer keyboard. That's it, nothing else. Now, Turing suggests that this question, will the computer often enough win at the imitation game, replaces the original question. And there's some certain vagaries about how often a computer would have to win. Turing is clear that he's talking about possible computers, not necessarily actual computers. Certainly in the first half of the 20th century when Turing was writing, we didn't have any computers that could probably pass the test. Now that's open for some debate. Okay. If you want to try this for yourself, interact with a computer program, not really a computer program, but with websites like Cleverbot or something like that, program chat machines. These things don't necessarily do the best job, but they do an okay job, maybe a disturbingly good job. Now, here's an interesting question, though. In the imitation game, what we're imagining, by definition, is that the computer is imitating that it's a human being, that it's supposed to be imitating that it's thinking. That's why this is called an imitation game. Why would the fact that the computer wins at imitating suggest that it's really thinking? And just to be clear, Turing really does think that computers, or at least possible computers, are thinking, that they're not just simulating or imitating what you and I do, but that they're actually thinking. If you look a little bit farther down on the handout for Module 10, you will see this distinction. Is it on there? Oh, maybe it's not on the handout. Never mind. There's this, initially in Searle's article, okay, about computers and brains and programs, he distinguishes what he calls strong AI from weak AI. AI just stands for artificial intelligence. According to weak AI, and by the way, everybody accepts weak AI. You do, I do, Searle does, Turing did. According to weak AI, a computer is a very helpful tool for understanding what it is for something to have a mind. On strong AI, a computer is a mind. It is conscious. It's not just simulating. It's not just imitating. It is a mind. Again, why would anybody think that winning at an imitation game means that the thing's actually thinking? Well, here's why. I submit that Turing is sympathetic with a certain kind of behaviorism. Now, behaviorism is a kind of physicalism. A behaviorist thinks, there's a couple different versions of behaviorism that we'll talk about, but a behaviorist would deny anything like dualism. What do behaviorists think? Well, on early versions of behaviorism, what we might call analytical behaviorism, being in a mental state, say being in pain, is just a matter of being disposed to perform certain kinds of behavior in certain conditions. So what is it to be in pain? What is pain? It's just a kind of disposition. If I bang my shin on the coffee table, I limp around and grab at the side of pain and say ouch and probably curse a little bit. That's all that it is to be in pain. It is to be apt to perform certain kinds of behavior in the relevant circumstances. Now, this was a thesis that had some popularity at the beginning of the 20th century, but nobody really, not really, goes in for analytical behaviorism anymore. Certainly not the way that I've got it spelled out on the handout for this module. After all, we can probably start thinking of counterexamples fairly quickly. Well, what if the guy's acting on stage? What if he doesn't really feel pain, but he's just trying to do what other people are doing? You might be disposed to perform the right kind of behavior in the right kind of circumstances, and yet you're just not really in pain because you're faking it. So I don't mean to suggest that Turing is sympathetic with analytical behaviorism. But I do think he's sympathetic with what we might call methodological behaviorism. According to methodological behaviorism, it's not the case that being in pain just is that kind of disposition. Methodological behaviorism says something about how we should proceed when we're trying to understand the mind. According to methodological behaviorism, we have to ignore inner testimony and statements about internal awareness and things like that. What we should be doing, according to the methodological behaviorist, is looking to the best and only evidence that we've got that someone is in pain, for example, their behavior. And that's understood as widely as you care it to be. It includes both verbal and physical behavior and maybe even a few other things. The only evidence, says Turing, that we've got that you're in pain is what you say and what you do. That's not to say being in pain just is to say and do that stuff. It's only to say that's the only evidence that we've got. Quite literally, to quote President Bill Clinton, I can't feel your pain. I guess it's a paraphrase of Clinton, but never mind. Okay. I cannot get inside your head and know for certain whether you're in pain, whether you're in love, what you're feeling right now. All I've got, all I could have, is your behavior. Now you can see then why Turing thinks that the Turing test is an argument that a computer is thinking, that it's having thoughts. The best and only evidence that we've got is that it performs the right kind of behavior in the right circumstances. That, for example, when you ask it questions, it produces answers reliably. And that's what the machine that passes the Turing test is supposed to do. By the way, it's also what Searle's Chinese room is supposed to be able to do. So that might be worth thinking about as well. Now, one of the reasons I like putting things this way, again, and my point right now, is simply that Turing seems to be sympathetic with methodological behaviorism. The reason I like talking about things this way is to kind of respond to a very common objection to the mere suggestion that a computer could think, that a computer could be conscious. The typical response is, well, computers can't feel emotion. They can't feel happy, sad, they can't know what it's like to be in love. They don't feel anything. They're just computers. Well, how do you know that other human beings are really having those kinds of feelings? How do you know that they're in pain, that they're in love? You can't get inside their skin and feel what they're feeling. You can't really, not literally, feel their pain. The only thing you've got, the only evidence you could have that someone else is in a particular mental state, say pain, is that they're performing the right behavior in the right circumstances. The only evidence that you've got, the only evidence you could have that someone is in love is that they're performing the right behavior in the relevant circumstances. I don't know what that is. They talk about their beloved all the time. They swoon when their beloved walks by, whatever. So here's an interesting question then, and this is a bit of a rhetorical question. If you don't think that the computer's thinking, why are you so confident that other human beings are thinking as well? What Turing points out, I think this is reproduced in your handout, but if not, here it is. What Turing suggests at one point is that if you're convinced that a computer isn't thinking things, you really need to be what in philosophy we call a solipsist. A solipsist endorses solipsism. That's the view that I am the only person who exists. Okay? Because after all, the only way you can know that you're in pain, that you exist, but other people, you have no access to their inner life. If you think we can't know that a computer is thinking because all we've got is its behavior to focus on, then you really shouldn't be so sure that other people are thinking because it's only their behavior that you have to go on. And that, for what it's worth, is supposed to be a ridiculous conclusion. Solipsism is a bad thing. So why does Turing think that passing the Turing test suggests that a computer really is thinking? I submit because he's a methodological behaviorist, and Turing says you should be too.